Hello guys, welcome to geometry lessons. Now this is lesson 100, transformation from matrices. Before we begin, congratulations, we made it to lesson 100. Yikes! So let's move on to the new concepts. It says matrix. A matrix is an ordered rectangular arrangement of numbers. The matrix below is a 3 times 4 matrix because it has 3 rows, 1, 2, and 3, and it also has 4 columns, 1, 2, 3, and 4. That's how we write the size of a matrix, okay? Also in the new concepts, we have corresponding numbers in 2 or more matrices are those that are in the same row and column in each matrix. To add the matrices, simply add the corresponding components together. Let's see in example 1, adding matrices. We have here to add the 2 matrices. Notice that the size of this matrix, according to the definition, the new concepts, is a 2 times 2 because it has 2 rows and 2 columns. And in the definition it says that we can add the corresponding elements. So 2 plus negative 1 is 1. 3 plus positive 4 is 7. 0 plus 3 is 3. Negative 1 plus 0 is negative 1. Please don't write on your books, okay? Let's compare to the result. Since it is correct, then that is our answer. That's how we add the matrices. Another new concept we have is a point matrix. A point matrix is a matrix that represents the coordinates of a vertex in a polygon or in a line segment. For example, here we have this quadrilateral, and it says that the vertices have the coordinates of 2, negative 1, 5, negative 2, 3, negative 5, negative 1, negative 3. To represent all of these in a point matrix, all we have to do is to place the values of x on the top row and the values of y on the bottom row. For example, the vertex R has the coordinates 2, negative 1. So we're going to place x on the top, 2, negative 1. 5, negative 2, well, 5, negative 2. 3, negative 5, well, 3, negative 5, negative 1, negative 3, negative 1, negative 3. This is what we call a point matrix. Having said that, let's see example number 2. Adding matrices to a point matrix. The purpose of a point matrix is to make or to perform a transformation on a figure that is placed on the coordinate plane. For example, here we have segment AB and they're asking us to move it using the point matrix. If you notice, this is x and this is y. They're asking us to move 1 space to the right and 1 space up, since both numbers are positive. X represents a horizontal movement and y represents a vertical movement. If the number that represents the horizontal movement is positive, then the movement is to the right. If the number that represents the vertical movement is positive, then the movement goes up. We have this graph and we have to apply this. All we have to do is to add the matrices. The coordinates of point A is 1, 4, 1, 4, and the coordinates of point B is 5, 2, 5, 2. And we have to add this point matrix because it represents the movement or the transformation we're applying to segment AB. Corresponding sides or corresponding elements, 1 plus 1 is 2. 5 plus 1, 6. 4 plus 1 is 5. 2 plus 1 is 3. Now this is like the image of my transformation. This would be the pre-image and this would be the image. If you can notice, if you can look very close, you can see that it has a prime on the top. So 2, 5 Okay, now it's better. 2, 5, 2, 5, 6, 3, 6, 3. As I said, we moved one space to the right and one space